I'm going to be talking about modern extreme programming, hopefully give you a flavour of how extreme programming practices have developed and become more extreme. Extreme programming, or XP. If I say XP, I mean extreme programming. Extreme programming is a bit of a mouthful, so I will probably say XP. XP is a set of kind of values and practices, both team practices and technical practices that people have found are effective in helping us to build software, build the right software and build it in the right way. But there are really, I don't know why that keeps turning off. There are really two things that I hope you'll take away about XP. Regardless of whether you want to try the specific practices that I'm going to talk to you about, and they're kind of generally applicable. So one is that all of the XP practices are about feedback loops, establishing short feedback loops and getting them as short as possible so that we learn really quickly as we build software, and that helps us to build the right software. And the second thing is that all of these practices come from people looking at what is working well for their teams and then thinking about how they can do it more and do it, get more value out of that by turning it up to the extreme. And that's where the name extreme programming really comes from. It's just about doing things to the most extreme possible. I do apologise for the flickering. I don't know what's causing that. I'm Benji Webber. I'm a software developer based here in London. I mostly work with Java stuff. I'm only going to try and give you a flavour for some of the things that we've been doing and other people have been doing related to extreme programming. So if you've got more questions, come and find me in the rest of the conference or ping me on Twitter and I'll try and give you some more information. I currently work for an ad tech company called UNRULY, also headquartered here in London, but offices around the world. And I work there on various things, from our ad exchange, kind of real-time advertising, very fast, high-performing Java stuff, to some of our big data stuff, which is also Java-based. One moment, yeah.
I have a problem with your input of your laptop.
Right.
It's giving me a signal, yes and no.
Quick change. Should we try this one?
Do you have another connection or not?
No.
Yeah. Because it says invalid signal and then I have signal.
It's funny, it was working before we started, wasn't it, of course? Can try this one.
And how do I connect it?
Same.
Same. Sorry.
Fortunately, I brought a spare laptop, so we're all good. Always be prepared. So as long as the battery lasts on that one, we're good.
I can plug it in.
I do somewhere, but it'll be fine. It's fully charged.
But you're like a phone on ground. Sorry.
Cool. Sorry about that. Where do we get to? We're talking about UNRULY. So UNRULY was founded about 10 years ago and has been doing extreme programming from the outset. The founders were some of the early people adopting XP at their previous company. And I've been there for several years myself, and it's been really interesting to see how XP has developed, both as the community's learnt more, our technology's improved, which lets us do things to a greater extent, and indeed as the company has scaled from when I joined about 10 people up to well over 200 now, which affects some of the practices that we can do. We also run a meetup group called Extreme Programmers London, where we get a lot of XP practitioners from around London come along and talk about new things they've been trying, what's working well for them and their teams, and that's some of the new practices we've adopted have come from there, and we get actually people from all around the world coming to that as well. But the story of XP starts about 20 years ago, which seems like a long time in software development, but less time, or at least it makes me feel old to think that this film came out 20 years ago, Independence Day, as all the marketing for the new one, I'm sure, is reminding you. But also 20 years ago, this guy, Kent Beck, was starting work on a software project, and his observations from that software project would later become extreme programming. He later went on to write a book in, I think, 1999 called Extreme Programming Explained. It's a really great book. I definitely recommend you read it, despite it being a little old now, because actually all of the practices outlined in here are still considered fairly extreme by most organisation standards, and it's still very relevant today. So in it he explains why he's done it, and he says that his goal was to take everything he knew about software development and turn the dials up to 10. That is, to do things to the maximum extent, the things that are working well, do them as intensely as he could imagine, and do less of the things that weren't working well or were unimportant. So the name extreme programming really comes from that, turn the things that work up to the max. What's happened since then, in the last decade or more, things haven't stayed still. We've been able to look at what's working for our teams and turn things up even more, particularly where technology allows us to do things more extremely than was possible at the time. And that's really what I want to talk about today. So we'll give you a brief introduction to 4 areas and explain how we've turned the dials up in those areas. Firstly, I'd like to talk about how we've taken the idea of pair programming and add more people, and which is called mob programming. I'd like to talk about continuous integration and how we've managed to turn the dial up on that. Briefly about collective ownership, taking that to the next level by broadening it, applying it to more things. And I'd like to talk about test-driven development and applying those principles to our production monitoring and what that allows us to do. Each of these only at a high level, but do come and chat to me afterwards if you want to know more. So pair programming to mob programming first. Pair programming is possibly the most controversial of the XP practices. In the XP book, it suggests that you should only write all of your production code paired, that is, having 2 people working at the same computer all the time. Just out of interest, how many people here would say they pair program on a regular basis? Okay, maybe about 10%, 20%. What about at all? How many people ever pair? Okay, it's more like half the room then. So that's quite interesting. So the practice is not unheard of. People know about it, they use it quite regularly, but it's not got the level of adoption or acceptance as some of the other practices, such as automated testing, perhaps. Why is that? Well, it's perhaps hard to convince management sometimes. It looks like you've got 2 people doing the work of 1 person, and that can't possibly be efficient, right? It's also hard to sell to developers often. It definitely reduces our hiring pool because we're upfront about the fact that we pair program on all of our production code. There are lots of developers who want to put their headphones on and go and sit in a corner and hammer out code all day, and they feel they're most productive in that environment, and they don't want to work in a pair programming environment. That's not to say that pair programming is only for extroverts. I'm quite introverted myself, and a lot of the best pair programmers I know are, but it can be tiring and draining. So why do we put ourselves through it? I really do think it's a great way of writing software. Not only do you learn really quickly, and it spreads knowledge around the team, but just like all of the XP practices, they're about establishing and shortening feedback loops, keeping them as short as possible. Pair programming actually gives us a whole load of feedback loops. There's the learning, there's making sure we're building the right things, because if we go off on a tangent, something that's unnecessary, you've got someone to bring you back. And it's the shortest possible feedback loop for code review. rather than waiting hours or even days to get someone to review your code and then finding you have to go back and redo it or just accept the problematic code through. It's all reviewed at the time you're writing it, so you've brought that feedback loop right down as fast as short as it can be, which is great. It means that we can not only build the right things, but build them in the right way. So that's pairing. So how have we turned that up? As I mentioned, quite simply, we add more people to it. This is an idea that's been popularized recently by this guy, Woody Zuhl, who's a really nice guy. If you ever get a chance to go to one of his talks, I recommend it. In fact, we started mob programming after a couple of us went to one of Woody's talks and learnt about the idea and thought we'd give it a go ourselves. Woody defines mob programming as having the whole team working on the same problem at the same time using the same workstation. So whole team, for us, our teams are kind of 4 to 6 people usually. So small, agile teams, but getting the whole team together at the same time using the same workstation. Taking pairing to the next level. What does it look like? Well, this is our setup. We have quite big desks with plenty of space around them. And we have a big 30-inch screen for the person at the keyboard, who we call the driver. And everyone else sits round, and we have a big 50-inch TV that they can all see the code and what's going on it. And the way it basically works is you start talking about what you're going to build, and then you start building it as you go. So if you've ever had a design discussion about how you're going to build something, it's just like that, except you've actually built it at the end. A few more pictures. I think this was the first time we ever tried it. We found a really old TV, very low res, to try it out with. And we went out and bought shiny new ones when it was working well. One of the interesting things was how viral the adoption was. So a couple of us went to Woody's talk, heard about it, thought we'd give it a go, and then the other teams observed us doing it, and they all started trying it. And we now all mob program quite regularly, because we found it works well for us. And this is basically the idea of XP, look for what works well and try and do it more. And we all have a very similar sort of setup. The adoption was fairly low friction because we're already pair programming on basically everything that we do. One of the interesting benefits is because all the code has to get articulated to get written by the person who's at the keyboard. It helps improve the code quality as well. A couple of practical things. We rotate round who's doing the typing, so people don't get bored, everyone stays engaged, helps us to remember to take regular breaks and so on. 5 to 10 minutes at the keyboard seems to work quite well for us. That's kind of enough time to write a couple of tests and maybe implement something. We started out by, it was a new idea to us. We said, okay, well, let's take whatever's we've got on a Friday, and let's mob program on that and see how it goes. It worked well enough that we continued to do it. We did find that there were some tasks that it works well for, and some things it works less well for. It's probably poorly suited for things that have poor feedback loops themselves. For us, it takes quite a long time to configure our production infrastructure when we want to make changes to that. And if you've got something that's very slow, then having a mob of people together, people quickly get bored because they're sitting there twiddling their thumbs, not doing very much. So now we tend to, as we pick up a new task as a team, we'll discuss how many people it makes sense to work on it and have a group form as we need it. But why would you do this? Surely having 4, 5, 6 people working on a task can't possibly be as efficient as having everyone doing their own individual things. And I think that is actually probably true. We probably could get more things done if we all worked individually, but often that's not actually the most important thing. There's often huge disparity in value between different things that we could be doing, and often to the business it's more important that we can achieve a particular goal as quickly as possible than that we can get lots of different things done, particularly when that goal is learning something that will affect the next thing that we do. Is this thing useful? Is anyone going to buy it? for examples. And mob programming really does help us to move more quickly, we found. Why is that? Well, I'd like to say that you can't stop the mob. For two reasons. Well, the overall reason is that the mob programming is the closest I've ever come to what I call an ideal day. That is that everything goes exactly as planned, and secondly, there are no interruptions. Things go as planned because you've got everyone's expertise all together. When you encounter problems, you're more likely to be able to resolve them very quickly, and you certainly don't have to go off and find people and arrange meetings and discussions about them. The mob just keeps on rolling over whatever obstacles there are. And secondly, there are no interruptions because, well, if someone wants to go take a break, they just peel off the mob, go take a break, and the mob keeps on rolling, and they come back and join when after their break. If they have to go to a meeting, same thing applies. If someone comes in that needs help from someone in the team, same thing happens, although often they think, oh, well, you're all together, you must be having a meeting, and meetings are obviously more important than software development, so I will not interrupt you. And I've lost the screen again. One moment. Maybe not plugging it in was overconfidence. Or maybe I just talked on that point for too long. There are lots of ancillary benefits. A lot of the meetings that we have in software development are about synchronizing people who are doing different things. So there's no need for design discussions or architectural discussions because you have them as they arise naturally as you build the systems. There's even no need for things like stand-ups because why would you need to talk about what you've been doing and what you're going to do if you're all working together all the time anyway? And because you're agreeing things as they come up and you're all working on them, it really engenders a sense of collective ownership in what you're building because everyone is involved in the decision making and buys into what you're doing. There are things to watch out for as well. We found mob programming is great for dialing up what the team is great at. But just like when you get any group of people together, you can amplify negative attributes of that group of people as well as the positive. So we found we have to watch out for things like overconfidence, like groupthink, like nitpicking, that sometimes come out when you have a group of people together. It's been really helpful to have external observers from other teams that can highlight when this kind of thing happens. But in general, we really do find that it's a great way to dial up what the team is great at and help us to move faster and increment faster as well. Any quick questions on mob programming before we move on?
How long will you keep going when you start?
How long do we keep mob programming for? Well, sometimes we'll do it all day, sometimes not. It depends on the task. Sometimes you'll mob for a while and realize that what you're doing is not really a task suited for mobbing, and you might end up splitting up or reforming. Yep. How do we deal with conflicts on things like design decisions as we are building stuff? Well, it actually seems to be easier than when pair programming because you've got often an odd number of people or certainly more people to discuss and come to a decision. I don't think it's any different to if you're trying to come to a decision in a meeting. We certainly don't. There's less chance of a deadlock than in a pair, for example. Yeah?
What sort of tasks are suitable for programming?
What tasks are suitable? It's particularly good, I think, for when you're starting on something new that you really want the whole team to be able to understand, agree on the kind of basic or the fundamental architectural decisions you're making, and be able to support it. I'm going to come on to how we deal with support a bit later. But where you need the whole team to really understand and buy into what you're doing, it's a great tool for that. It's also great for team building, but just by mobbing regularly, we become a more effective team, even when we're not mobbing, I would say. Okay. Pardon? Do we mob document? Actually, we have found that actually some teams outside of our product development team have been trying out mobbing, and one of the things they've done is mob document editing. Although I think they were doing it slightly differently. They have used collaborative editor like Google Docs, and then they all talk together and edit the doc at the same time. So slightly different. We'll do more questions at the end, so if you think of more, and now it's locked again. So next, I wanted to talk about continuous integration, which I think is perhaps one of the most misunderstood of the XP practices. I might have a bit of a rant on this topic. So Kent Beck says in XP Explained he prefers a synchronous model of continuous integration, that is, waiting for the tests to finish and making sure that we haven't introduced any conflicts or regressions before we move on to the next thing we do, which is quite different to how a lot of people do continuous integration now, where maybe they push some changes and they get notified at some point in the future if they've caused a problem, and do it asynchronously. As developers, we love asynchronous things because they feel more efficient, but there are lots of benefits to doing this kind of thing synchronously. For one, it gives you a strong incentive to keep your build and test suite very fast, because what we found, once it gets beyond kind of 2-3 minutes to run all of your integration tests, then people get bored and they want to run them less frequently, and they want to integrate less frequently. So you have an incentive to keep things fast. It also means that it really does form a feedback loop as part of your normal process. So you've completed a conceptual set of changes, you integrate them at that point, you wait and see, well, have we caused a conflict with anyone else who's working on stuff? If we have, let's address it now before we find that we're both taking a refactoring of some common thing in different directions. Let's address it early while we're working on it, while it's fresh in our mind. It means that if you've regressed something, you fix it then, rather than having to context switch when your build system informs you in some amount of time that you've broken something. So there are lots of benefits of keeping it synchronous, although it's maybe not very popular. Kent Beck also says in XP Explained, if the goal is to deploy a website, then deploy a website. I think David Farley, one of the authors of Continuous Delivery book, actually says that continuous delivery is really what continuous integration is meant to be. And I think that is the case. It should not just be integrating the code if possible, it should be integrating our changes as widely as possible. And that's basically what I want to talk about how we've dialed it up. The thing I'd like to have a little rant on, if I'm allowed a diversion, is that build servers are not the same as continuous integration. Continuous integration is the practice of integrating our code regularly with the rest of our team, maybe wider. Build servers are a tool that may help or not with that, often not. In fact, the way, sadly, end up seeing a lot of the CI tools being used is more continuous isolation than continuous integration. People end up using the tools to make it less painful to keep their changes isolated from other people. We talked about asynchronous builds. I think they're a weaker form of continuous integration because you don't have the same feedback cycle. People often use build servers to help them deploy out to test environments, which are kind of by definition isolated. We could be integrating wider, and I'll come on to that in a moment. You even see people using their build, allegedly CI servers, to run tests on feature branches in source control. This is literally the opposite of continuous integration. You're keeping your code isolated in a branch and using your build server to make it less painful to you that you're doing that. And people often use build servers to make versioning less painful. If you've got lots of versioned artifacts, dealing with the complexity of bumping versions, of checking if you've broken downstream dependencies and so on. But again, versioning really is the opposite of continuous integration. If you've got two different versions of something, then by definition, you're not integrating your changes with both of them at the same time. Not to say that any of these things are bad, it's just that they're not continuous integration. People often think, I'm using a build server, therefore I'm doing continuous integration. But back to the topic. In XP Explained, Kent Beck says aim for a 10-minute build, run all your tests within 10 minutes. Actually, that's rather too long, we found. 2, 3, 4 minutes at max is best. I think our slowest system takes 10 minutes to deploy, and that is really painful. And he also talks about releasing once a quarter, which in the context, back when you're having to burn CDs and ship them as your release process, is quite fast. But nowadays we have the web, and we can dial that up, and we can release much more quickly than that. And that's basically how we dial up this practice. Rather than saying 10 minutes build, we release to production within that sort of max length of time, and preferably shorter. And we really can release that frequently. This is a photo of one of our dashboards in our dev area. We've lost the x-axis. This is an afternoon. And each of these vertical lines is a deployment of one of our systems to production, all the way to production. And you can see we really do release quite frequently. This is just a team of 4 or 5 people releasing systems very fast all the way to production. So it's possible. We do it. People are sometimes surprised. And people often think that's terribly risky. We're changing production very rapidly. And in fact, the opposite is true. We're forced to make it boring. It's boring, which is what you want from a release process. You don't want it to be exciting. It's boring because you are forced to automate everything, manual steps, introduce errors, and are slow. You're forced to make sure you've got great test coverage, because if you don't, then you don't have any confidence that allows you to release this fast. You're forced to have great monitoring, so that you know if you do cause any problems in production. And everyone knows how to do it. And you're releasing such tiny chunks of work each time. If you think about how much you can get done in, say, an hour, when you actually start doing this, you realize how little you get done in an hour. And you know exactly what you've changed. It's much less risky than if you were to save up all of your changes for 2 weeks, a month, however long, and then release them all to production at once. If you break something then, you've got no idea what's causing it. It's going to take you a long time to diagnose that. So in fact, I do believe it is safer, and indeed we found that. We have not found the risk to be a problem. And it gives you a competitive advantage if you can release this fast. The best example I like giving of this is there was an occasion where we had an email from a salesperson who, early in the morning, and they said that they had this deal that was worth a lot of money, but it was contingent on a feature in our ads that we didn't have. When the team got in, we discussed it, estimated it, didn't think it was much work. We put it to our stakeholders. They said, yep, it's worth doing. So we started work on, implemented a bit, released it out to production, went discussed with a salesperson, demoed it. Wasn't quite what they wanted, went back, iterated, and by lunchtime we had released a feature in production that fulfilled the client's needs and meant we could win the campaign. So it really can be a competitive advantage to be able to do this. It's not something, I think switching business priorities like this is maybe distracting and not something you should do all the time, but when you're in the habit of releasing rapidly, then you're enabled to do this if the need arises, which is great. I'm going to leave questions till the end now, because with my laptop shenanigans, I'm running out of time. I want to talk about broadening the idea of collective ownership, applying it to more things. Collective ownership is, in contrast, I think, very simple XP practice to grasp. It's just the idea that anyone on the team can edit any part of the code base, improve any part of the code base. There's no strong owners who don't have, like, service A is owned by Alice and service B is owned by Bob, and only they can make changes to their respective services. Anyone's able to work on it. It's pretty necessary when you're doing pairing, and it's a natural consequence if you're doing mob programming, because you're all working together on it anyway. So how do we dial it up? Well, basically we apply it to more than just code. So I've just been talking about how fast we're able to release out to production. If we were to have a separate operations team, you might rightly think that they might not be so happy with us doing that. keeping up with the pace at which we're changing things in production when they're being asked to support it. So we've broadened the collective responsibility. So our teams look after not just the code, but the whole life cycle of the product. So that includes keeping it running in production, the operations side of things, which is one of the reasons we're able to release so fast. It also means that because we have the responsibility of looking after it in production, we can have the freedom to release as fast as we like. And we're able to better balance the trade-offs that are involved in building software. So as developers, we often love new shiny things like microservices in Ponylang or whatever the latest trend is. We have to balance that with the kind of simple, well-understood solutions that degrade gracefully, that we understand well, and decide what balance we're comfortable with as a team the team that's going to be woken up at 2 in the morning if what we've done goes wrong, or when it goes wrong. So that's one way we've broadened it. What we've then found is we're able to move so fast, build things so quickly, that often the bottleneck is what should we be doing next? What's the most valuable thing for us to do next? So we've broadened it even further than that, and we've said that our teams are product development teams. They look after everything around a product or a set of products. And that's not just building it, it's not just keeping it running, it's helping the business come up with new valuable things that we can add to those products. As developers, we're intimately aware often of what's possible with what we're working on, and business knows what's valuable. Together we can come up with new valuable things. And as a team, if we're having operational pain, our balance of work will shift towards making our systems more reliable. And if we're short of things to do, our balance of work will shift towards research, investigation, prototyping things that might be valuable for us to build. So we've really broadened the collective ownership idea, and that does limit the number of things we can do at once, just like mob programming. But because we're not handing off things to another team, we're not handing off releases to another team, we're not being handed off work from a product team, we're able to move more quickly. So finally, I wanted to talk about the ideas of test-driven development and applying that to our production monitoring. Testing in production kind of often used to be the sign of a lax attitude to testing or QA. People who can't be bothered to do any testing would just ship everything out to production and see if it worked or not. But more recently, I think it's starting to become accepted that the opposite is true. Not that it's not worth testing before production, but the only way you can really be confident your systems are working is if you're also checking them in production. We're in fact able to do a lot of different types of testing in production if you think about it. Some of these might seem risky, but again, if you do them regularly, you are forced to find ways to do them to make them simple and to make them not risky. We often do user testing in production, where we might release a feature we're working on to a small group of users, see if it affects their behavior, or a sample of users that we're testing with. We might do acceptance testing in production, where we release a feature to production that's feature toggled only on for the person we're building the feature for, and then get some feedback from them in the production environment they're comfortable with before iterating on it and ultimately making it available to everyone. And there are quite simple techniques for doing these kind of things. At the end of the day, they tend to come down to glorified if statements that may check roles or turn things on for percentages of users. And it's pretty safe to do so once you've got that framework in place. We even do things like exploratory testing in production and even load testing. We regularly, I think once a week, send 10 times our normal traffic to our production systems and check that we're able to cope with that. Again, something that seems risky, but in fact, we do that in a controlled environment. It backs off if it causes a problem, and we do it when we're at the office and able to respond to any problems. Much better we know about it at the time than at 2 in the morning, when we're much less able to respond to a problem if it does occur. And this gives us a sliding window for knowing if there's problems in the future. So there's loads of testing we can do in production, but I briefly want to focus, as the last thing, on behaviour testing and taking the ideas from test-driven development and applying those to our production systems. Why would we do that? Well, there are loads of reasons our production systems might stop working, and releasing a new version is only one of them. Time is a constant variable. There's always things people haven't anticipated that are time-related, like leap seconds. Even something that's as seemingly simple as month periods are not always simple. Users and data is another one. We like to think of our systems as stateless bits of behavior. We have version 1, we change some how it behaves, release version 2, and it behaves slightly differently. But in reality, we often have databases attached, giant blobs of state, and users shoveling in new data all the time, and that data does affect the behavior of your production systems. If there's lots of data, it may run more slowly. Maybe some features don't even work at all when there's a lot of data. If there's data you've not expected, it might change the behavior of your systems as well. And if there's one thing users are good at, it's coming up with uses for your systems that you hadn't anticipated. Third parties. We've lost the missing parcel off the back there. We often rely on third parties to make calls out to third-party APIs. Do our systems behave as expected when they're down, when they are slow, when they give us back data that we haven't been expecting? Unless we are checking that they are behaving as expected, we don't know. Traffic. Maybe you run acceptance tests when you release software. With how many users do you do that with? Are the features still going to behave as expected when you have millions of users? Or vice versa. And there's the low-level rubbish infrastructure that developers like to ignore. Do your features work as you expect when the network is congested, when there's packet loss, when DNS servers giving back incorrect results? Any of these things can start happening in production at any time. Your system is basically a ticking time bomb. It's going to go wrong in production, but are you going to know when it happens? So how can we know when it happens? Well, we can apply the same ideas from our normal automated testing. What is an automated test? I think it's a small program that checks some aspect of behavior of your code, and that program can either pass or fail and let you know whether that behavior has changed or not. And really, our production monitoring doesn't need to be any different to that. There's quite a variety of different models for production monitoring. Some systems use kind of active checks, passive checks, but ultimately they tend to come down to, at some point, you run a program that checks some aspect of behavior of your production system, and it can either pass or fail and tell you whether or not it's working as expected. Sadly, production monitoring is often very focused on inconsequential things like, is my server up, or is there disk space, or even is my application running, which I don't actually care about that much. I don't really want to be woken up if a server goes down. I may not even want to know that a server's down. Things I care about much more are things like, am I making money, or are users able to log in to a system, or are they able to purchase things? And we often write tests for these things, but we don't think about monitoring them in production, so we don't really know whether or not they're still working in production or not. But ultimately, the monitoring checks and our test suites are pretty much the same thing, and you can often even run the same tests that you've written for your testing the system as you're building it, particularly if they're integration tests hitting HTTP endpoints, or if they are acceptance tests driving the web application. You can often point those at production with a bit of thought about how you isolate the changes they're making, and really have much better confidence your systems are working as you expect. So if we do apply those principles, build up automated checks in production, then we have much higher confidence our systems are working. But there's a secondary benefit as well. Test-driven development, like all the other XP practices, is about getting short feedback loops. It's a short feedback loop that our code's doing what we expect, but it's also a short feedback loop for improving the design of our application. When we test drive something, we write a failing check, the red state first. Then we'll write a little bit of code to make that pass, usually the simplest code you can think of to do that. And then before you go and write the next failing check, you should do some refactoring to either make the implementation better or your tests better. And one of the things that drives you to do that is that it's often hard to write the next test. And this is what, when you hear complaints about unit testing, it's often due to people missing this step or not applying this step properly. Because if your tests have a lot of duplication, if your tests are brittle, if you have excessive amounts of mocking in a test, that's your test screaming out to you, my design's bad, please improve me, and that's what you should be doing in this step here. And if you do that, then by following the test-driven development loop, it really does improve the design of your code as you go, because you're forced to address these issues. But by applying it to our production system, we get the same feedback loop, but at a higher level to improve the design of our production systems and architecture as well. So we could start off by writing a failing check and deploy that all the way out to our production monitoring environment. So let's say we're building a new system, we might want to check that a user can log in, we'll build a test for that, get that running in production, can anyone log in production, then it'll be failing in a failing state. Maybe we'll acknowledge it if we have alerting on it. And then we'll go and start implementing the feature following our normal test-driven development cycle. And then we will, at some point, we'll reach a deployment point where the feature works well enough that when we deploy it out to production, it will make that check pass. And then we will have confidence it's working now in production, and we'll have confidence it remains working. So we're building up this suite of tests in production that give us confidence. But then, just as the refactor step for test-driven development, before we move on, often we find it's hard to monitor things in production. And that can be a step that, if you listen to it, can improve the design of your production systems. If you are finding that it's hard to monitor things, maybe it's because your application has, or your service has too many responsibilities and it's worth splitting them up. Maybe it's because you're having to delve into private database states to find the answers you need, and we need to expose that, maybe publish it out to our monitoring system. There's a number of things that we can improve about our design to make it easy to monitor things. And by following that cycle and discussing the problems as a team as you build stuff, it forces you to have the discussion and improve on your high-level system design as well as your code. So you get the same kind of benefit. So wrapping up, and then we'll have a bit of time for questions. We've talked about pair programming and turning up the dial on that, adding more people, and having mob programming, working the whole team together at the same workstation on the same problem at the same time. We've talked about continuous integration, what that really means, and turning up the dial on that and applying it to more than just and more than just integrating our code, but integrating into our production environment as well. We've talked about broadening the idea of collective ownership, not just code, but the full product lifecycle. And I've talked about test-driven development, applying the same principles of building up automated tests and feedback loop that improves our design, and applying those ideas to our production monitoring as well. But the two key things, all of the XP practices are about establishing and shortening feedback loops, finding things that help us learn rapidly as we build software, so that we build software that works and that we build the software people actually want. And all of them came from the teams looking at what was working for them and then trying to work out how they can do that to a greater extent, turn up the dials and do things to the extreme that are working well. Thank you very much. We've got a few minutes left for questions, I think. Yep.
Do you ever get non-developers involved in mobs? I'm thinking about sort of like non-controversial stuff like testers who don't really write code, but also maybe even users.
That's a very good question. Do we ever get non-developers involved in mobs? And yes, we do. Particularly commonly specialists. So we have some specialist roles, like we have UX specialists, we have some product managers, we have some operations specialists who help us be better at handling and managing our infrastructure. And they'll often come and mob with us to help us out with problems and to further their own agendas as well. So, for example, the things that they'd like us to be doing better that we're not. So that happens a lot. We occasionally, less frequently, have pulled in people who actually want us to build stuff for them and had them working with us. It's harder to do that because they're in kind of separate teams in the company and they're less available. But that's something I wish we could do more of. Yep.
My question is about the continuous deployment and specifically in organizations where an error is not just like a glitch on the website where it could be sending orders to the market to buy. A lot of money could be lost. And there are examples of hedge funds who literally got drowned by one error. How do you approach that? This is probably something that no one would be able to accept that you come up with something that hasn't gone through for all these things.
So the question was continuous deployment. Could you still do that in an environment where an error has large financial consequences, not just a problem on a website? So we don't have as high consequences if we break things, because we're mostly doing advertising them in, but there are still significant issues. Like we could break some very large publisher websites around the world, which has significant financial impact. We're processing quite a lot of money at any given time, and we could break that as well. For us, it's actually the risk increases as the change gets bigger. We're normally quite happy to deploy even after beer o'clock on a Friday, but if we've saved up 2 days of changes because we've not been following this properly, then we are not going to do that because we're quite scared of what we've done. So from my own experience, the risk is reduced as the change set gets smaller, but I don't have experience working in a high-risk environment, as you say. So I can't really speak to that. I would suggest that probably you want to have protections in your production system to limit the damage that they can do, rather than rely on reducing your release frequency. But
Well, quick question about you used some great pictures earlier of you guys actually doing it.
Yep.
I guess I'm just working out the mechanics a little bit more.
Let's see if I can put.
You've got a large sort of screen where everybody's looking at it.
Yep.
And that mirror to whoever has the screen and the keyboard.
Yeah, let's just go back.
Is that your setup? Because I'm going to try it.
Yeah. So yes, so this guy here is using a screen here at 90 degrees, and then it's been mirrored here, so everyone else sees exactly the same thing. Yeah. Any more questions? Yeah.
Talking about the mobbing and the shared ownership. Do you think it's something that could be applied to every team, or do you see anything in certain things that could make this not possible to be applied?
Do I think these practices can be applied to every team? No. Every team is different, and these things have only come from teams looking at what works for them and doing it more. So you need to look at what works for the team. There's lots of reasons it might not work: personalities, the business attitudes to things. So none of these things are silver bullets that will solve all your problems. These are practices that have worked well for us and have worked well for other people, but what works for your teams might be completely different. Yep.
Is the mob the only people that are in the room?
Is the mob the only people in the room? No, we actually have a quite large dev space where all of these teams, we have 4 of these size teams, and they're all located in the same area. When we started doing it, we did have a problem with people getting too loud, which was causing a problem for other teams, but that's been less of an issue as we've got more used to it. I think for me, the ideal setup would be having a room per team, so you can all, like a war room, you can all talk to each other, but you're not getting distracted by what other teams are doing. Yep. Does this preclude remote working? That's an interesting one. So yeah, a lot of our practices are very collaborative, and we don't really do remote working. We do it occasionally, but it's not part of our normal practice. I have experience with remote pairing, which works quite well, where we just share the screen so that we can see what each other are doing, and we have a laptop so we can actually talk to each other as well over Google Hangouts. So that works well. We haven't actually tried remote mobbing, having someone remote, so I can't really say whether that would work or not. It's not something we've done. Any more, or should we finish there? I think we're done. Thank you very much.